Hello everyone. So welcome back to the good stuff that we have been doing. Today we're going to try to compute this integral is from negative infinity to positive infinity of tan inverse of sine x divided by e plus cosine of x. Now notice here that if we replace x by negative x, for instance here I, so let's say for example let's say we have f of x here to be tan inverse of sine x all divided by e plus cosine of x, then 1 over x. Now let's say f of negative x would be tan inverse of, there you have sine of negative x divided by e plus cosine of negative x. Then you multiply this by negative 1 over x, because this x here would be negative. So this would equal negative, the negative here for sine factors out. So this would be just positive 1 over x times tan inverse of sine of x divided by e plus cosine of x, because cosine of negative x is cosine of x. So which means that this function is an even function, because f of negative x simply equals f of x. So since this function now is an even function, so this integral would be twice the integral from 0 to infinity. Now if this was odd, if this was an odd function, let's say we have an x squared term here. If we have an x squared term here, this integral would equal 0. Just to be sure. So since this is an even function, this will be twice the integral from 0 to infinity of tan inverse of what? Sine x all divided by e plus cosine of x. Now we're going to use a very curious dx over x, of course. We're going to use a very curious fact here, and that curious fact is that if you have f of x equals to, like, tan inverse of y for any function, tan inverse of y is equals to the imaginary part of the logarithm of 1 plus I times y. This is a very curious fact that if you do complex numbers, it is easy to prove. So having this in mind, so that means our integral, which is I, is the imaginary part. So our integral is twice the imaginary part, twice the imaginary part of the integral from 0 to infinity of what? Of the logarithm of 1 plus I sine x all divided by e plus cosine of x dx over x, of course. So this will be twice. Let's go up a bit. Oops. Let's trying to bring this down. Okay. Oops. I did some maths here. Oops. Oh God. Oops. Oh God. All right. So yeah. Let me take out this. Take this out. So this will be twice the imaginary part of what? Of the integral from 0 to infinity of the logarithm. Now we can write this as logarithm of e plus cosine of x plus I sine of x all divided by e plus cosine of x dx over x. So let's draw some lines. So this would equal, on this part, this will be twice the imaginary part of the integral from 0 to infinity. Now e to the cos x plus I sine x is e to the ix. So this will be logarithm of e plus e to the ix all divided by e plus cosine of x dx over x. So this is the imaginary part. Now the bottom part of this logarithm is always going to be a real number, so we can just discard it because we need only the imaginary part here. So this is twice the imaginary part of the integral from 0 to infinity of the logarithm of e plus e to the ix. So e to the ix dx over x. So we can write this as twice the imaginary part of the integral from 0 to infinity of the logarithm of, we would have e times what? 1 plus e to the ix over e dx over x. Now, since the imaginary part of log e is actually 0, so we can discard log e and write this as, let's do a different color here. We can discard it and write this as, this will be twice the imaginary part of the integral from 0 to infinity of the logarithm of 1 plus e to the ix all divided by e dx over x. Now this will be twice the imaginary part of the sum, because we know for sure that logarithm of 1 plus x is the sum as n runs from 0 to infinity of -1 to the n plus 1 x to the n over n. So this will be the sum as n runs from 0 to infinity of -1 to the n plus 1 e to the inx e to the inx all divided by e times what, dx e to the n rather, dx over x. So this will be twice the imaginary part of the sum as n runs from 0 up until infinity. Now here we could write this as cosine of nx times sine of nx, but the cosine part is the real part, so we're going to write this as, this is -1 to the n plus 1 sine of nx all divided by e to the n dx. Okay, so let's go down and continue. So we will write this now to equal, so this is twice the imaginary part of the sum as n runs from 0. No, we are done with the imaginary parts. So this is the imaginary part here, because it is the point being that e to the inx is cosine of nx times plus I sine of nx. So if we have a sum of -1 to the n as n runs from 0 to infinity of e to the inx, and we need the imaginary part, we only need to take the sum of the sine side part. That is why we are having twice the sum to be of n equals to 0 to infinity of -1 to the n plus 1 of okay, sorry, I think I missed something here. I forgot about the integral all the way, so let's see. Oops, trying to push this up. Wait. Okay, this sum here, when we get to this sum part here, there is an integral here, so let me just take this out. Okay, yeah, I forgot this integral completely. So this will be twice the imaginary part of the integral from 0 to infinity of the sum of, as n runs from 0 to infinity, of -1 to the n plus 1 e to the inx all divided by e dx over x. Okay, now let's continue from this part of the board. Oops. Yes. So what we have, let me just take this out. So what we have is twice the imaginary part of the integral from 0 to infinity of the sum as n runs from 0 to infinity of -1 to the n plus 1 e to the inx over e to the n dx over x. So we can swap summation and integration. We can write this as, okay, like I said, this is twice the imaginary part of the integral from 0 to infinity of the sum as n runs from 0 to infinity. Because we need the imaginary part, we can just discard the imaginary part and we just write -1 to the n plus 1 sine of nx all divided by e to the n dx over x. So this will be twice. Now we take the sum as n runs from 0 to infinity of negative 1 to the n plus 1 e to the n. Then we'll write the integral from 0 to infinity of sine nx all divided by x dx over 2. Of course, this integral, this is Dirichlet's integral. The integral from 0 to infinity of sine of nx all divided by x is equals to pi over 2 so long as n is a positive number. So this will be twice times the sum as n runs from 0 to infinity of negative 1 to the n plus 1 e to the n times pi over 2. So the 2's cancel out. We will get pi times the logarithm of 1 plus 1 over e, because you have to recognize that this series is a series for logarithm of 1 plus 1 over e. So we have shown that this integral here is equals to pi times the logarithm of 1 plus 1 over e. So thank you for watching, and please do subscribe to the channel. Bye.